P459 has a 30-degree angle on it off of center, so there's a couple ways that we could go about this geometry. Is to draw this from the top and kick the block over, and then our intersecting square is just a from the right plane extruded out both directions. We could draw the top prism, leaving a center line through the middle that would allow us to set up a plane and tilt it over 30 degrees, 60 degrees on the adjacent angle if we needed it, and then still be able to extrude our intersecting block through the part. So let's do an example of each, since this is a fairly small part. And I went into inch fractional. We're going to switch over to millimeters, grams, and seconds. Alright, so our first set of bodies will be top plane, sketch. We'll go with the center rectangle. And probably didn't need to do that because I'm going to end up with all of the verticals and all of the horizontals automatic. So 3-point center rectangle will allow me to skew this off. Alright, and the block is 45 by 45, so those are equal. And then I need at least one of these. Smart dimension. Let's see if we go to our arrow, 30 degrees off of center. I think I'm looking at that right. And assuming that the height is 30, 50, and 30, that would give me 110. Alright, so for this part, don't think it really matters, so we're going to go to the 110. Alright, and then what that allows me to do is go to the right plane, open a sketch. We'll stay with the center rectangle, and this block is, I believe, 25, 30 square. So select our two edges. Don't need the face in there. Set those equal. That'll be vertical to the origin. And then the let's see, that is pointed to the center mark. No? Okay, misread it. It's 80 overall. Okay. So having to look through the isometric here, the 30 goes to the center mark, which comes back to the center mark of our geometry, and then an additional 50 above that. Alright, so that's easy enough to change. And we were 60 on each side, so features, extrude boss base, and we would go 120. And that needs to be midplane. Okay, so double clicking, we'll switch over to 80, and then rebuild. That shows the geometry. Alright, so as far as orientation, if this orientation was going to be easier to rotate one of these sides and have this block maintain, we don't get too much of a chance to, or haven't had much of a need for the direct editing. So I'm going to move copy bodies. We're going to move out of, okay, we're in rotate. So we need an axis to rotate about. So don't really have an axis, or at least a center line. So if I go 60 degrees, oh, and then the body to move. Alright, so that rotates it out of position, so we really would need to be at the center, so I need that axis anyway. Alright, so it's not going to hurt anything to leave that. We'll try it on the next one. Alright, so I'm going to hide that solid body, and again, if you don't see your solid bodies, That's because I have turned this folder on. I believe the hide at the top level does the same thing. The top level feature, hide and show, does the same thing. Alright, so I go back in and I'm going to create a second body. Oh, we're on the same strategy. Hold on a second. I'll go to corner rectangle and I'm going to direct edit this into the same position anyway. So midpoint, 45 millimeters, 80 millimeters tall, and then I'm going to place a center line for my reference geometry. Alright, that feature gets extruded, 45 millimeters, midplane. And midplane is kind of important because we want that segment there to work from. We can show the sketch, go into reference geometry plane. From the flyout, we'll pick the top plane and the center line. That sends it into coincident to the line, and then it automatically went to perpendicular. We could do parallel, but then I can also go to the angle and set it to 30 degrees. And then if we flip the offset, which way do I want that to go? Alright, so when I draw this, that's going to send it a little further that way. And that's going to be along the axis that I really want, so I'm going to go to the adjacent angle and flip the offset, because I think that's the plane that I really want to generate from. Alright, so we open up the sketch. We're going to use that center line again. Center rectangle, 30 by 30. And set those equal. 30 millimeters off of the base. Let's go back to Control 8, Normal 2, so I have that normal reference. And then we'll go to the origin or to the center line. In this case, horizontal. Features, extrude, midplane, 120 millimeters. Alright, and then we can hide plane 1. And if I go to isometric, then my other body was up and down. This one's laying flat. So back into direct editing, move copy bodies. We'll rotate about... Okay, so that's the one. Okay, that's the body that we want to rotate. Rotate it about that line. 90 degrees shows me the preview. That looks okay. Actually, that rotated me right into the same position. So when I come back and we show their body, there it is. So we're off by one rotation. So let's see which one is which. Once you have the second body in place, then I'll pick up. Alright, so I'm going to go back and hide or show sketch 3 again. And sketch 3 stayed in position, so that's still a little bit of a problem. Alright, because I wanted to rotate about that edge and then rotate about that line. Alright, so let's do a rollback and see if we can rotate first. Alright, so move copy bodies, rotate. Still need to rotate this one. Rotate about that line 30 degrees. See if it shifts. I don't think that shifted the right way. So we'll go minus 30 degrees. Not too many places in SOLIDWORKS where we get to use the minus. And then if I roll forward, now it appears to have disappeared, but we have solid body 1 laying on top of solid body 2. Alright, so if I hide either one of those, I've rotated them into the same position, and when I hide the sketch, then we have pretty much the same item. The other move copy body for translate. Let's go ahead and pick that second body. And I can just drag along Z and we'll pull it out some distance. And it went to minus 68, so I'm going to change that to 60. Just even number. It was hidden, or it is hidden, so I need to show it. And then there are my two bodies with direct editing translating the geometry. Okay, so kind of an explanation of direct editing thrown in there for the mix. Alright, so that was 459, and we'll save. Alright, and then in inches, cylinder intersecting a cylinder. So 0.75, 3 inches long, 1.5 inch, and 1 inch from, so basically centered on the part, so that would be a good place for midplane and midplane. Alright, so on the top plane, open up the sketch, go into our circle, 3-inch diameter, features, midplane, they gave us 2 inches overall. Yeah, that's not going to quite look like the picture, is it? Oh, 3 inches to the side, 1.5 inches on the face. So if something looks wrong, it's probably wrong. Alright, so rebuild, that looks a little bit better. Right plane, sketch, we'll go right back to the origin. And then depending on our design intent, we may want this to, we'll probably want this to always be centered. Then as this grows or shrinks, the center cylinder grows or shrinks, this will always remain intersected at the origin. All right, so 460. Alright, we'll close this one out. Let's see, this is in metric. So whole pattern is the same for gasket, gear housing, and gear cover. So that would either lend itself to a multi-body part or going to a top-down assembly using those advanced techniques to make sure that those holes line up to some sketch. Alright, object is symmetrical about the horizontal center line. So we can generate an offset. What do we have for radius? 110, centered 100, and 0.9. So that being the case, if I generate this center line, the holes are not equally spaced. So that doesn't lend itself to a pattern. 10 millimeter holes times 14 and 3 millimeters thick. Okay. So based on the offset, I can go into part metric. We'll center this about the origin. So front plane sketch. I'm going to go ahead with the center lines. I'm not entirely sure that I need them, but it'll help us with the perception of the geometry anyway. So let's go ahead with line. And I'll select the midpoint, and we'll go to make that coincident. And one that I haven't gotten used to is the midpoint line. So if I were to go midpoint, pick that up, then that does the kind of the same thing as making the midpoint symmetric. And then those the midpoint coincident to my vertical line. And notice even though I made that symmetric, the object symmetric, the endpoints did not pick up that symmetry. So the lengths can stretch even though the objects will stay in the same orientation, so that selection is pretty important. Alright, so if I were to make the endpoint symmetric, that would give me a different an additional result or a different result. But once I add the tangency, and let's go ahead and mirror that so we can see how this moves together. Alright, so nothing really defined, everything's capable of stretching or shrinking at this point. We start adding the dimensions, 220, and we had, well, that was a full radius. So it's capable of up and down side. Alright, so the 220, I was looking at the 110 radius thinking, well, that's half of that, but that wasn't really part of the discussion. These two items are going to be separate. Alright, so we're going to select the chain, so everything gets picked, offset the entities. We have 10 millimeters on either side, so 20 millimeter offset. And then bidirectional, nope, 10 millimeter offset. Doesn't need the full dimension. Reverse and caps and everything gets turned off so that it's not part. And then construction geometry. Base geometry goes to construction. So where I would have to select the chain again, that does automatically. And then the offset geometry could go to construction. So go ahead and accept. That gives me my shape. Alright. So let's go ahead and extrude the 3 millimeters. And it doesn't really matter which way it goes. Jump back into solid here. Sketch. And we can go back to that original sketch. And we'll have two centered, and we would want to watch picking up a tangency there. Those are going to be equal. And we'll go ahead and set the 10 millimeter diameter. We need to mirror, but since I left the mirror line in the other sketch, then we're going to convert. And then those will come in as object lines, and then we convert them over to construction lines. So those two items get mirrored, and we'll turn off or deselect the vertical. Okay, so now we have enough to add our dimensions. So 74 and 74. Alright, so one in place. Got to go ahead and set the diameter. Those two are going to be the same as my seed part, so all equal. If we can identify, I can create a construction line where I can identify, there's my center point, that becomes the vertex, that is direction 1, that is my third to generate the angle, and that'll give me 30 degrees. So I don't have to create construction lines if there is convenient geometry to work from. If there's not, we would just draw in a construction line. Mirror, features, extrude cut, through all, and accept. Alright, we go back and hide sketch 1 to clean up, and there's our gasket. So the interesting part is, let's see, gear housing, gear cover, this wide open space over here, depending on what the the reliefs or the gear housing geometry looks like, that seems like an awful wide gap to not have any contact pressure. I'd say based on distance, I would like to have I'd rather have them equally spaced. So let's look at that as a solution. So didn't need to hide, I need to suppress that option. So let's go with, let's show. I'm going to put the a new sketch in, 10 millimeters at the center to start, and we'll extrude that feature through. I'm going to go ahead and select the chain and convert that geometry in. And then we'll select the chain again, switch it over to for construction, and see if that can be part of my sketch feature. So extrude cut through all, generate the first item. So if we were to go 14 equally spaced, so I can hide that sketch again. Let's go ahead and show that one because I think that'll be part of my pattern. Cut extrude 2, and we want a sketch driven pattern, or maybe a curve driven pattern. Curve, sketch. Now I don't have points for a sketch driven pattern, so it's going to have to be a curve. And it's going to let me select the chain. I got the features. Alright, so we did not make that a complete curve. Alright, so there's a since this has the starting and stopping points, let's edit the sketch. And that may be why this needs to be a separate sketch. There is a tool under the spline tools. Spline tools, and it's called Fit Spline. Alright, so curvature is equal, but it will make this one complete curve. Alright, now separation, inflection points, minimum radius, it's constrained to the original geometry. A little bit of separation there. So that would be a concern, but let's see what it does. Alright, so I'm going to pull. Not sure what that point is. Alright, so we're going to go ahead and accept. Oh, that was the original geometry. So that was why it had to be separate. So let's go to convert entities. Alright, so that mismatch on the fit spline concerns me a little bit, but for our example it'll be okay. Alright, so that one point where it kind of joined the splines up, we would either, dare I say it, fix it, or find some way to put a dimension on that geometry. However, I do have the complete curve to work from, and I would have to resolve that offset issue. Alright, curve driven pattern, spline from sketch 3. 200, probably not. 14 equally spaced items. Features and faces are the cut extrude. And then, what is our separation? Yeah, that ends up right on the deviation in that curve. So we'd have to resolve a little bit of that issue, but it gives me 14 equally spaced items is the point. So hide the sketch, save the gasket, and then we have our what if scenario. And as long as that geometry was generated out of the same sketch and was consistent between our parts, there wouldn't be a positional mismatch between the gasket and the housings. Alright, so our first we'll suppress and then unsuppress. And then after we've made a decision about this area of the gasket, what is there, what's not there, then we could go back and delete our what if scenario, whichever one doesn't make the to the final design. So 110 and 110, that almost looks like the housing, but we don't have the name. So for our assembly, we're going to see if these actually fit. But the dimensions look just enough off on the 50 millimeters. We're not dimensioned the same, so this would be a concern that if I wanted that previous gasket to match this, we need to pick up our geometry. All right, so 3 bosses, thicknesses, and then the tapped holes. Okay, object is symmetrical about the center line. This one has the 110 offset, 90 on the center line, so pretty much could use the same geometry. So this might be a good example. I don't think they continue this on. Now they kind of keep the same through the next two parts, but different geometries. All right, so M8. So pretty much I want to just create my my sketch geometry and start building from there. I think this lends itself to the contours and regions. So that being the case, we're in metric. I'm going to go back to Open Recent and grab 461. I don't necessarily want the boss extrude, but I do want the sketch. So Control C. Jump back into the part, go to the front plane. Well, let's see how much fun it generates going to the top plane. Control V. There's my sketch. And if, you know, in the design intent hindsight being 2020, if we'd included those holes instead of the separate feature, we would have had all that geometry in place. So as it stands, we're going to make this geometry match even though we weren't given the same dimensions. We can verify those dimensions, but I don't want to trust it at least that far. So horizontal. Let's see, center will be coincident. Alright, so downside of the sketch is that I have to reapply at least some of the relations, if not all of them. Alright, so this wasn't too bad on the geometry, but I have to be prepared to go in and make those adjustments. Alright, so I'm going to put points. For the hole locations, and because, well, I do want to do that sketch-driven pattern, so I'm going to leave those out. All right, we're going to stay with the main geometry. All right, so hole at 50, 20 millimeters. And it's part of the 110 number. So since that picks up, we'll go vertical. Oh, that was an additional 55. That's why it looked weird jumping that far in. All right, so 55 and 50 from the center line. So have that shape in. Let's see, radius of 25. Let's go with the center point arc, because then I can go right into the tangencies. I do a radius of 22, so into the tangent arc, pick up the endpoint, bring it off correct, and off to coincident. Alright, so it picked up the coincident, did not pick up tangency, so I'm going to set the tangency. Let's see, these two are going to be equal. Put in our dimension of 25, radius of 22. Double check those numbers real quick, so that looks good. Nothing on the other side. So that, and that. Center line, mirror, completes our geometry. Let's see, those are 110, so create our two circles. Okay, and since the center points pick up our dimensions, then those are equal, and then those three will be equal. And we have a diameter of 32, 60 on all three boxes, our bosses, and 32 on all 3 holes. Okay, so that gives the shape. Alright, the end tab then. Let's see, we'll bring over our line. Let's see, that fillet could pretty much go into as a separate item depending on the depth. Yeah, we'll just mirror the line and then pick up the tangent geometry. And our dimension goes to 155. Alright, so be careful with the points. And a radius of radius of 30, but that means that something got picked up here, so alright, symmetric, that works, tangent works, 28.05 off of something, so let's see, symmetric, tangent, so it's got to be on this one. Nope, horizontal works. What is the coincident to? Coincident to the outside. So I inferred something. Not sure where I inferred it at. No equal, tangent, and distance. So we'll come over tangent, coincident. And I'm not seeing where it's picking up that number, but we're not getting the correct size. Okay, there it is. Coincident to a point way over there. And that was my suspicion, is that I was picking up some geometry. It was just which of those little boxes was going to be the one that I needed to get deleted. All right, and then let's see. We have 2 holes at 20. The one on that side is not called out, so assume it's going to be 22. Also, and until we find out different, it doesn't look as big as the others, but. Alright, so that gives me my my base geometry. Alright, so 20 millimeters all the way across the bottom. And we'll go ahead with the build. Alright, so extrude boss base. 20 millimeters on the thickness. Selected contours will be 2 shapes. It jumped into thin feature on me. I do not want the thin features, so we need to get rid of that contour and go to the region so that it doesn't see that open, well, open in relation to the other contour as a thin feature. Okay, so that provides the base. We're going to go 60 millimeters up, so that's going to be an extrude boss base. Or, nope, not 60 millimeters. Oh, the 60 millimeter bosses are going to be the next, and they are radius of 5 to a height of 5. So that can be offset from surface. And since it's going through, I was debating on the from and picking that face, but if I offset from surface, it's 5 millimeters from that face. And then we'll go to back to our region, select the contours, and it'll be the 3 circles. And then if we change the direction, no, direction's correct, then how about reversing the offset? Okay, so let's see, select the face. Oh, did not select the face. pick something, just didn't pick what I expected it to. Alright, so reverse the offset. We see that it's built up. And we can go ahead and complete. Alright, so that gives me that geometry. Alright, going to the next step. Pick the sketch, extrude boss base. We have an overall height of 120, so 120 millimeters. Oh, got an extra in there. Selected contours is going to be inside, outside. If I could get the region, but the region didn't pop up conveniently, easily, so we'll go with the contours, and that'll give me my wall height. One more that I missed. We didn't get into that geometry. So that being the case, let's edit the sketch. Oh, nope, didn't need to edit a sketch, edit the feature. And then inside of that feature, now that's going to make it thin feature again. Oh, you need to get into the contour, and really didn't want to include the hole. It's going to shift me over, thin feature, yeah. Okay, well, if it's going to create an issue, yeah, it won't create that much of an issue. We'll go region and region for our geometry, and OK. Alright, so that adds it into the mix, and then the next one was just going to be the holes anyway, so sketch, cut, extrude, and then we can go through each of the hole locations. Flip the direction through all, and that'll go into our geometry. Alright, so that gives us everything but the hole positions. So we're going to show, and on this open up this sketch, and I'm going to put points in place. Oh, no, that one wasn't centered. And actually, now that I think about it, as I centered that one on the spline driven, and it should have been off some distance. Alright, so let's go ahead and convert. Switch over to construction geometry. We can mirror the points just like we did the holes. "74, 74. Alright, so since these dimensions aren't given, we have to go to the gasket. Alright, so same thing, find the vertex, one endpoint, the other endpoint, 30 degrees. Alright, so all of that gets mirrored. Okay, maybe not all of that. There we go, mirror those. We're going to mirror those points. Well, I already did the mirror on the top. Okay, got a little too much selected there. You can see the preview. It's not duplicating points up here, so that's good. Alright, so creating that sketch, then this is my okay. Getting button happy. Alright, my sketch pattern. And we just pick any one of those. S key, hole wizard is going to be ANSI metric and M8 by 1.25. There it went. M8 by 1.25. Has a depth of 30. We'll go 20 on the thread engagement. Set the position for 1. Accept. And then now those two become the sketch-driven pattern. So wherever there's point, go to the selected point. Let's see, we go to there we go. Go to the centroid. And so we're not going an offset or a reference to some geometry on our seed part. Go ahead and accept. So when we're doing a lot of holes, having that pattern or repeating that pattern for different geometry, having those sketch points speeds up the process, makes it more consistent. Hide the sketch. We'll throw in a save here since this is getting a little complicated. P4-62. Alright, so next is the radiuses. So it said 10 millimeter radiuses except where specified. So if I were to go to the face, 10 millimeters would be all the way around. We have 5 millimeters on the bosses, and it looks like 10 millimeters on the outside, so I can't pick the face here. So we're going to go with the interior, see if there are any other 5 millimeter bosses. Not that I can pick up, so 5 and enter. And go ahead and accept. Around the outside and the two edges. And that becomes a 10 millimeter. Alright, and because the tangency is turned on, tangent propagation, it's going to find its way around all of that interior segment. Alright, so let's see what the gasket looks like in an assembly. They were metric parts. Doesn't really matter that I put them into the assembly. They'll come across. And we can always change back over to millimeters. Insert component. 461 comes in, so it's been rotated, but we'll go coincident. And then this is also where I could put in a mate reference. Concentric. Alright, and then it's still able to rotate, so one additional hole. And then positional, we would be able to see how these fit or how much the gasket is able to move. Alright, so if I set a color here for the gasket, it'll stay. We can either set it at the component level or the part document level. Component level is going to stay in the assembly. Part document level will change it in the part file. So some contrasting color. Go ahead and save. Alright, so we can close all those back out. Jump into our next gasket and I think, okay, housing. Oh, and then this is the lid. Alright, so we still kind of have an assembly look here, so inside, outside. So what are we doing on the bottom geometry? It has the radiuses, has the relief. So this could be a multi-body part if it doesn't get too complicated. All right, so other items putting in to the holes, whatever goes internal to our geometry. So let's treat it as a multi-body part and have it create the assembly as a master model strategy or in going through that process. Alright, so I'm going to go with a layout sketch first. This is in inches. So we'll go to the top plane. See, it doesn't really matter, so let's go circle and circle. And then there's going to be a couple more circles since I'm drawing, and I just saw a tangent flicker, so I need to go back and check. Yep, sure enough, inferred tangency. So outside, radius of 2.75 times 2 to get to a diameter, 0.75 through, and then they did change up 0.75, 1.25, then these two are the same, but the centers are different, so 0.63. And then the outside diameter radius of 1.75 goes to 3.5. Distance between then is 3 inches. So we'll use the centers there. And since it's capable of moving, we go to horizontal. Alright, so the trim then, I will go ahead and trim this to make the a little easier to get to, and then we'll just delete that section. Maybe not. Alright, so since it thinks that something's attached to it, or the dimension, I still got rid of my dimension. Interesting. Put the radius back in, call it good. So I don't know if it was just that going from diameter to radius that it was having a problem with. Alright, so my offset then, we didn't do center line on this one, we went just to interior. So inside radius 2.25, so that's going to give me my wall thickness. Let's go ahead and put in the radius of 0.5, and it's saying both sides. It's an interesting way of looking at it. Alright, so if they do 0.5 interior and 0.5 exterior, oh, there we go, radius of 0.25 on the outside, 0.5 on the inside. So if we put that 0.25 in and then go 0.5, that will make a larger radius on the interior, so I'm not sure that I trust that number. We're going to turn off the bidirectional. We'll reverse the dimension, put in the 0.5, and accept. Oh, and I left my geometry, construction geometry on, so I have to move it back. We'll go with the sketch fillet. Oh, sorry, sketch fillet. 0.25 for the interior. Okay, exterior of the part, interior of the shape. And then 0.5. And go ahead and accept. Alright, so in order for those two centers to be the same, this would have to be a larger radius. 0.5 wouldn't pan out. Alright, so that gives me the shape, it gives me my geometry. We can we could go ahead and put the points in. So given those shapes, let's go ahead with, I don't really care about the radius now, but let's go with an offset. And that one actually, or no, offset geometry will be for construction. Reverse the direction, 0.25. Alright, so center line. We'll set up our points. So we have one vertical, one in the middle, missed. And that being the case, since we have the symmetry, I'll go ahead with horizontal infinite length, set it to the origin. And we'll continue with the points. One over here, one vertical, one on the angle, one at the intersection. Alright, and my offset dimensions are a little bit in the way, but it did get fully defined. Alright, we'll make sure that those are staying coincident to the base circle. Alright, so we have a couple of angles to put in. Always starting at the vertex, picking the outside two, 45 degrees. The inside then, we set symmetrical. Now it's saying 45 degrees all holes. So inside, outside, 45. That one did pick up. Not sure why those jumped back. So rather than making symmetry, I'm just going to set those horizontal. Interesting. Alright, so we got to figure out what went on there. And we'll mirror. Okay, so I'm going to have one of those situations where it doesn't move. The points don't move. Nothing's going on, but it's going to show under defined and bark at me. Alright, so still minus on the sketch. So let's go ahead and save this. This is going to be P4, 63, and 4. And master model so it doesn't get confused with millimeter. Alright, so one more time, edit. Alright, so the test is that it doesn't move. I don't know if it's part of the offset. Let's try a fix. Okay, so over define. Not surprising. Can't move them and nothing's going on, but it's not going to let me get to a defined condition. Alright, well, we'll live with that. Alright, so my offset geometry, let's fly this in. We're going to make both the top and bottom as separate bodies in this one part. And we would do this where we want to show this as an assembled piece or one part number. What I'm not going to get in the part is the fasteners. So if that's an issue, we'd have to possibly send this over to the assembly, or we kick it out to the assembly and manage the part numbering just a little different. All right, so 1.75D 0.38. So let's go with, alright, before I forget, we will change this to layout. That's going to be our base sketch. And I don't want to share this sketch across too many bodies, so the layout strategy is going to be a little bit better. Alright, so select chain, and select chain, and convert entities. Features extrude. We're going to extrude to 1.75, reverse the direction so that our two pieces meet at that level. And then if I wanted to shift to contours and share, we'd go to the side, make that one so it just creates the bottom. Alright, and then I'll share the sketch by extrude cutting. And this is going to be offset from surface. We have a distance of 0.38, so pick my surface, 0.38. And again, we're going to need to select the contour, so just the interior. Yeah, I think it works okay with leaving sketch 2 in there, but I don't want the whole sketch to be in have the opportunity to create any conflict. Alright, then sharing the sketch one more time. Nope, I'm not going to be able to do that because those bosses are still in the layout. So that gives me my base geometry. We'll open up a sketch, convert the entities, features, extrude, and that boss 1.63. So again, offset from surface. Actually, we need to stay with the blind in condition, 0.63, And other than doing the math and getting 1/4 of an inch, we can go to surface, face, or plane, which takes this sketch, moves it down here, and then 0.63 up from that face. Alright, having done the math, I would expect to see 0.25. We'll open up the next sketch, and this could be on the bottom. Doesn't matter that much. Extrude cut through all. And that'll pick up the majority of the geometry. So 1/4 20 by 0.75. Alright, so we're going to go with the face. We're going to try that sketch-driven pattern again, but because of the complexity, I don't know if it'll just pick up my points or if it'll try to do something additional. So we will go to tap tool, ANSI inch. Specification is for 1/4 20. If we're going to be 0.75 deep, we'll need to be one inch or so on the hole depth, 0.75 of threads. And position the first item. Okay. So double check, layout has the positions, and again, it'll either work or we'll have to put them individually. Sketch-driven pattern. Selection is going to be for the layout. It found all of the points and my point locations, so that's good. And everything looks like it came across, so we're going to call that fine. Alright, so may have to add additional geometry, but I'm going to go ahead and bring this to a new folder, and this will be the P4-63. Double check my number here. Oh, and then we left the radius, so radius of 0.25 on both bosses. Alright, so still inside of the sketch, no interior, so the outside walls here are sharp. That means that I'll still need to pick just the one edge, and dimension of 0.25. Okay, so since that's not part of the folder, we need to add it to the folder. Move it. Alright, we'll save one more time. Alright, what that can do then is, don't really want to suppress. If we just come back and hide the solid body, that works. Or we could right click on the first instance and our first feature and hide show. Alright, going into my next geometry, this is the cover piece. Alright, and it goes up 0.25, so basically I'm going to draw this upside down as to what's shown. Still kind of trying to decipher the build up here, but we'll go with our geometry. Kind of looks like, oh, there is an inset here, so may have to add just a little bit more. 7.5, okay. Should be able to build that out. All of that's going to work out okay for through holes. And still 1/4 20, okay, and then 5/16 for the positional, and then we get the ribs. I don't think that we're going to be able to do that as rib geometry, but we'll try it. Okay, and the ribs are just slightly slub flush, so it might work. Alright, so except for the offset being a little bit different, I think we're good. Alright, so same thing on the top. We'll open up the sketch, and I minimize that when I needed to fly it out of the way. So, top sketch, select chain, convert entities, and then this is going to be just a straight 1/4 inch. And going the correct direction, 0.25. Alright, so I can kind of flip this over, open up the next sketch, And if we select the outside geometry or the chain, then we will offset interior. And we're still going to have that same problem with that interior radius. So we're going to have to measure that, but I think that that radius may be, no, I know that radius is going to be an issue, so let's do this instead. We'll grab just those two objects, offset. Offset geometry doesn't need to be construction. And we're going from 275 to 175, so 1 inch. Doesn't look like it's going to let me do that. Okay, so that being the case, I'm not going to fight it. We're going to go to center point arc. And I'll just keep drawing the circle or the arc until I get it to the direction that I want. Merge, I may not even need to merge. So let's go with, we're given the 1.75, so let's go with 1.75 on our dimension and the inside of 1 inch. So I just want to see what the fillet will do at 1 inch. Okay, radius of 1, both sides. Since I don't have those at a vertex, can I pick those? Self-selected elements cannot be extended. So it's going to require, if we can't get to a fillet, it's going to require a tangent arc anyway. So we'll go tangent, tangent, make sure that two endpoints become tangent, are forced to tangent. And then those can be equal. And we set a radius to 1 inch. Okay, that gives a desired result. Distance is 0.5 off of the base, so we'll go ahead up with the feature, extrude. 0.25 is fine. So we'll stay with that number. At the center, 1.5 off of the center. We will go with the boss first. All right, so it's on center line. Diameter of 1 inch. And then we have a dimension 1.5. Alright, and then that's going to be a total height of 0.75, actually 0.38 from our geometry. So features extrude, 0.38. The ribs were the 0.25. Alright, so we're going to try the rib feature. And I don't know if I need the plane. We're going to try it on the face first. So rib from to. And what do we have for lengths? 1/4 inch wide. Isn't really telling me how far it stops inside, just that it stops inside. And if we had a radius to the outside, let's see, fillets and rounds. Can't really tell if that's a fillet, a round, or a chamfer. So it doesn't really give us that definition. It's definitely not a sharp. And the concern there is if it comes around to that intersection, will it pick up our geometry? So let's go ahead and accept, and then we'll switch it over to a min condition and give it at least 1/8 of an inch. And they're in 3 decimal places, so, or 2 decimal places, so 0.13. And accept. Min condition. Get out of my heads-up display. Oh, let's go to the bottom, 0.13, and see if we can generate a rib off of that sketch. Alright, so we're going to switch the orientation. reverse the direction. Thickness is 0.25. Selected body. Not sure what it's asking for there. Okay, rib is not bounded properly, does not intersect the part model. Okay, so that's kind of what I was curious about, if I was going to be able to operate it that way. So we're going to put in a plane, 0.12, 0.13 to make it round out okay. Flip the offset so it's subflush. Okay. Let's see, that one needs to be before so that I can edit the sketch plane and move that sketch up to plane 1. Alright, so we have plane 1. I'll go ahead and hide. And then sketch 10, go into the rib, change the orientation up to selected body, 0.25 wide. See if it's happy with that one. Not properly bounded. I'm pretty sure that's not going to be it. Alright, so it's showing me the correct, but not really giving me the desired result. So, that being the case, we have the rib in the correct orientation. Really didn't need the plane, but we're going to go ahead and go with our geometry. So, let's see, center was at is picking up the center lines. So let's go to midpoint. If I'm going to have to generate this this geometry, then we'll go ahead and include everything. Oh, nope, don't want to be at the quadrant. I need to be off of that that space a little bit. And if we pick the midpoint, which it picked coincidence, but it did not get midpoint, to the circle, place the position, go into the leaders, min condition, well, jumped over there. Okay, so one offset, bidirectional, cap the ends, make the base geometry construction, and 0.25. Okay. Offset. Oh, that was one direction, 0.125. Okay. And one more, offset, 0.125. Alright, so what changed is I need to identify these and go 125, and it let me link, so there we go. Alright, features, extrude, we'll pick the regions, or I'm sorry, the contours, reverse the direction, up to surface, pick our surface, there's our geometry. Okay, so that gives us the ribs. Fillets, they're still showing the fillets, and I didn't pick those up, so alright, so let's fly this in. So I can clearly see the fillets on pretty much all of this geometry in the section or the profile view. But I'm missing the call out, so our guess, 1/8 of an inch. Alright, so kind of why I left the 1/8 of an inch over there was so that we could build all of that out. Alright, so I'm going to go with the verticals first. Oh, before we get into the fillets, I have one more. S hole wizard should still be in the 1/4 20. Oh yeah, we have all the holes around the outside too. quarter 20 by 1 inch deep. Or no, just quarter 21, and we have a total of 0.75, so we have a total of 1 inch. So since that's not specifically called out, we're going to go 0.5 with a 0.75 depth. Okay, 0.75 is not going to work. Position to the center, make sure I'm on the right center. Go ahead and accept. Alright, so for these fillets, we're going to select and fillet. And since these ended up at quarter inch, I'd rather be on the underside of the fillet, so a little bit of clearance at the end. Let's see, up, over, around, connected. Alright, so just the verticals. Actually, I think that looks pretty good. And if we're going that far with it, I'm sure not going to make those as sharp to be the oddball. And then that fails because we're coming right up to the 0.13 that I left. So we'll have to see what that does for the blend. And actually, size-wise, that looks pretty big. So let's go with the 0.06, a little better. See if it'll find that blend and that blend. And I still forgot those holes. Alright, so we're able to get everything in one fillet. How about you? Yeah, it's all going to cooperate. And if not, I'll go to the fillet expert and say this is what we want you to do. Alright, so the issue is the blends. If this isn't a casting, I really don't want to take all of my geometry to that level because this is a lot of 3 axes. If there's no loading here, leave it sharp. I mean, that fillet is not that necessary except for breaking the edges. So in that case, my what if scenario, let's suppress out that one. And I lost my zoom. What's going on? Okay, well, I'm going to have to figure out what I did to my zoom. Fillet of 0.06. We'll pick the second one, go to the first item. Those could be minimum. Actually, out of that group, if I'm going to put fillets in there, I want to make it larger. And the externals, well, yeah, the externals are okay at 60, but it's going to be these internals that I don't want to use 1/8 of an inch end mill. Would probably want to make those up to 1/4 of an inch. So we're back to the, and let it be full rounds. Alright, so that would be my suggestion for machining and manufacturing. Oh, we switched the middle button over to rotate. How did I do that? Nope, there it goes. Alright, not sure what I told it to do. Another one of those. Alright, so we're going to go past the fillets. We're going to pick up our 5/16. So S, hole wizard. And we could make this a feature, but again, if I wanted to switch this over to countersunk or counterbore hole, we would need that geometry. So let's do that and then make the change. So simple hole, 5/16, .31 up to next. No near side and far side countersinks. Position for the first item, and OK. And we're going to be pretty close for a 1/4 to countersink anyway, but we'll give it a try. Alright, so hole wizard, layout sketch, sketch-driven pattern. Have our sketches, face feature. So it doesn't like this one. Geometry, there we go. Go with the geometry pattern. Oh, mainly because it's now got the second solid body. It's got to resolve which item is getting. So just the selected body, or we turn off and the auto select and say just that body. Okay. And we'll roll forward past the 2 fillet solutions. And let's say that I did want to take this over to a clearance, tighter clearance with a countersink. Then we would need to edit the sketch plane, go from face 1 over to face 2. Changes the direction through all. But then the advantage of the whole wizard is that I can go back in and say, I really wanted this to be a countersink. Flathead screw 82 degrees, size for 1/4 20, close fit, so we can bring that in and try not to lose too much. And just the selected bodies still. Picks up the geometry. Sketch pattern needs to be, well, either reselected geometry pattern failed. Okay, so not sure what the difference was there, but now we're in location, and that 1/4 inch is just going to break off of outside wall for our geometry. Let's see, the through holes, those didn't go through on this part, and the end game here is that we show the first body and we have both of our items. I can hide the layout sketch and then any other sketches that are kind of left in there. And if we're not if we're not concerned about hardware or what this is doing, then this becomes our base assembly. We can assign one part number to this part and not have to manage other items. All right, if I do want to separate this out then, and we would put this in its own folder, P4-63, and I want to name these beforehand, P4-64. And one of the considerations here is that I want to do the rollback rather than suppressing items. Suppressing items manages to rename these, or at least historically it has managed to rename these, which breaks some of the references. So if I have to edit after the fact, I'm going to use the rollback to put these in position and manipulate the geometries. Alright, so we have this thing called insert into new part, which would be just one of the items, or I can save the bodies. We're going to pick up part metrics, and the assembly is whatever. Auto assign the names. So there are my 2 parts with their names. We go into, we're not going to consume the cut bodies, visual properties, browse to the assembly. And save it. So now it has a location, picks up the templates, and we go ahead and do OK. Derive part to the units of the base part. So I'll pick that up, rebuild and save. Alright, so now here is the base part. Save one more time. We have an assembly with 2 derived parts that we can do assembly things to, like put in the hole fasteners. So let's see, is my toolbox on? No. So let's go ahead and add in the toolbox. ANSI inch, bolts and screws. We'll go with socket head. Find our countersunk screws. Pick the location. And that didn't quite work out. And we'll see if it figures it out. Length of 1/2 inch. And go ahead and accept. So a little strange. That one looks better. And we're just going to go through, except for that first one, and populate these holes. Okay, and then as far as the one interior, I'm not sure what it did. So coincident, and of course it went the wrong way. So let's go into the mates. We're going to have a bunch of mates show up here. We're going to flip the mate alignment so it gets in position, and then these are capable of rotating but not up and down. Alright, so that gives us our assembly geometry. If we had multiples of the other two parts, we have an individual base part. Alright, so those broken out separate, we can add additional geometry, make changes. And then we have the original master model. So anything that changes as far as top level geometry changes in here, it migrates to the parts, and then they migrate to the assembly.